record. Okay, there we go. So I think we're live recording. Yep, yeah, we are. All right, so I am going to, folks, I am going to do some more problems. Again, reinforce the concept that we learned about the chain rule, but now in a slightly more theoretical approach. So up to this point, we spent time on understanding how a chain rule goes. F circle G prime equals, F prime G, F prime of G times G prime. So we spent some time over that formula. Then we did a bunch of applications yesterday and the day before. And right now we're going to do something that is slightly more challenging in the sense that this is a bit more theoretical, so you need to understand the theory behind it in order to answer these questions. And I put some practice questions for this quiz coming up. So so do make sure that you pay attention. So it's a very important topic here. All right. So what I'm going to do here, folks, I am going to do problem 61 from section 2.5. That's the section with a chain rule. And this problem was also assigned as a practice problem, is a homework question as well. So f of x, here's a function. F of x equals f of g of x. So now what you see here, this is a composition of two functions where, and they tell us f of -2 is equal to 8, comma, f prime of -2 is equal to 4, comma, f prime of 5 is equal to 3, comma, g of 5 is -2. Okay, well, let me make that nicely here. Sorry about that. G of 5, there we go, that's a 5, equals -2, comma, move this out of here, and comma, and there's G prime of 5 equals 6. And find f prime of 5, it says a problem here. So find not that, so find, okay, f prime, capital F prime of 5. And now I have to apologize again. I have a lot of things popping up on my screen here, and I don't have a good control on the recording. So I noticed I watched one of the videos. I rarely watch these recordings, but I watched one of them yesterday. And there was a screen of me covering part of a board here. I don't know how that showed up there. So I'll try to kind of make sure that there's nothing covering the board here. But again, because of the small screen, this is a little bit challenging. So bear with me, folks, and pay attention here to the lesson, because again, things like that could happen, and you may miss some details, that may not be obvious when you watch the videos again. So here's the deal. The answer to this is the chain rule. So that's going to take care of everything that we need here. F prime of 5. Let's look at f. F is this one here. Is going to be, by the chain rule, as we said, is going to be f prime of g of 5. Remember that x is 5 in this case, so x is 5, right? Times, and then there's going to be g prime of 5. So this is the chain rule. It's as simple as, just writing down the chain rule. And it will be obvious here that g prime of 5 is 6 because that's given in here. So that's where my mouse is right now. So we really need to focus on finding f prime, this f prime of g of 5. But what is g of 5? We can replace that as well by, if we look here carefully, g of 5 is -2. So this really is -2 here, and this will become f prime of -2. And we can say, well, do we know f prime of -2? Yes, we know. It's here. It's the underlying quantity here. So there we go. It's f prime of -2 there, and that's 4. So the answer is 4 times 6, and that's going to be 24. So it's that simple. Now, what one thing you see in this problem is that this stuff here is not needed, and this stuff here is not needed, f prime of 5. So they just want to trick you folks. So you can think, well, maybe those are needed and I need to apply the chain rule that way. No, they're not needed. So all you need is just this formula. So we needed f prime of -2 for sure. We needed g of 5, which is that, and we needed g prime of 5, which was 6. All right, folks. So this is the answer to the problem. So the answer is this one here, 24. All right. So this is how we do problem 61. Let's do together number 62. Of section 2.5. All right, and number 62, if h of x is equal to the square root of 4 plus 3f of x. All right, so this is a bit trickier, right? Where, and it says here, where f of 1, they tell us here f of 1 is 7, and f prime of 1 is 4. Okay, so the question says find h prime of 1. All right, folks. So by the way, before I do this problem here, so let me remind everybody that that I posted practice problems in Canva. So do look at those practice problems for the quiz. I forgot to mention that as we started the class. All right, so over here, so let's go back. So we focus on finding that, and I think it's fairly obvious that we are dealing with a composition of functions, and this is a slightly trickier one. So let's recognize the pattern that we had at the beginning yesterday. So can we recognize a pattern like that? Yes, we can. So here we go. H of x is equal, and I'm going to replace that square root by the quantity 4 plus 3 f of x, right, to the 1/2. Now, how do we do the derivative of that? Well, we said that when we have a power like that, the derivative goes, you do the derivative as you just have the 1/2 power, and you take care of the derivative of the rest here. So h prime by the chain rule, again, a chain rule, I'm going to write CR here for the chain rule, is going to be 1/2 times the quantity 4 plus 3 f of x to the negative 1/2, which is 1/2 minus 1. This is, by the way, h prime of x. And then times, and we're going to say 4 plus 3 f of x, the remaining quantity prime. So this is going to be equal to 1/2 times 4 plus 3 f of x to the negative 1/2 times, and this quantity here is very easy to deal with because 4 primed is 0 and 3 f of x primed is 3 prime 3 times f prime of x. So this one goes away, by the way, folks. The constant here, the other constant is times f of x, right? So it's when we do the derivative that way, so it's 3 times f prime of x. All right, so this is the answer for h prime. Now, if you want h prime of 1, what you'll do is you'll substitute 1 in the formula for x here, and you'll say, well, that's going to be 1/2 4 plus 3 times f of 1, right, to the negative 1/2 times 3 times f prime of 1. And I'm going to see if I have these guys taken care of. Well, f prime of 1, yes, it is 4 there, and f of 1 over here, it is 7 here. So what I have is 1/2, really 1/2 times 4 plus 3 times 7 is 21. 21 plus 5 plus 4 is 25. So 25 to the negative 1/2, folks, times 3 times 4. F of 1, by the way, is 4. F prime of 1 is 4, we said. All right, so this guy here is simply, now what's 25 to the negative 1/2 is 1 over 25 to the 1/2, and 25 to the 1/2 is square root of 25, which is 5. So this is 1 over 2 times 1 over 5. 1 over 5 again is this guy, 25 to the negative 1/2 here, times 3 times 4, and that's 12 divided by 10, and that's going to be 1.2. So this is going to be the answer to my derivative question. Now this is a bit of a trickier problem. It's not that straightforward. And if I put a problem like this, I would perhaps put a problem like this for some bonus points, or maybe on the test rather than a quiz, because a quiz needs to focus on various other things as well, on some more routine stuff. But be aware that there could be a question similar to this one. And again, what I want you to do when you watch this video, so if you watch it at home again, do make sure that you stop here right before, right after I wrote the problem here. Stop there. Try the problem when you're on at home, and then see if you can reproduce these steps here or something similar to this discussion. All right. And there's a few other questions like that, slightly more involved. The 70s, so there's involving 3 functions and 4 functions and such. But again, that's more or less for the sake of art rather than anything that would be useful in practice. So I'm not gonna push any further with this chain rule situation here. What I'm gonna do, though, I am going to move on to something that still uses the chain rule, but it's not so obvious here that we will have to do that. So I'm going to move on, folks, to the new lesson, which is 2.6. And the title of the lesson is Implicit Differentiation. For whatever reason, doesn't let me write here. Implicit differentiation. All right. So what do we do here with this implicit differentiation? Well, here's the deal, folks. Here's the deal. Sometimes in math, there are formulas that you can actually not solve for. There are equations you cannot solve. There's equations you cannot solve by saying, well, here's a formula. This is the solution. So equations that represent various practical situations. And I've been telling this story for a while. So once I listened to a talk given by a doctor, the medical doctor was a researcher who was studying the biology, the chemistry of creating a drug to combat high blood pressure. So he was studying the action of certain chemicals. When you administer a number of certain chemicals to a patient. So basically, what happens in the blood? There's a number of forces acting on the blood vessel. Some of them because of the friction with the blood flow, and some other because of this the result of a chemical reaction. So he was setting up a number of forces, and it was like, this is the blood vessels, and there's forces from the inside, and there's forces from the outside, and there's forces from the chemical reaction. And he was setting up a number of equations there with derivatives, forces, in physics, that has to do with derivatives. And he was setting up a number of derivatives there, the equations of derivatives, and the equations looked really complex. So something like, and I'm going to give you an example here. I mean, this is a simplistic example, but something like this one here. So I'm going to take a look at, let's say, number seven in the book in 2.6. So it says here you have an equation like this, x to the 4 plus x squared y squared plus y cubed equals 5. All right, and you know, it would be nice to find the derivatives. You know, derivatives again have to do with forces. So remember in physics, folks. Let me just remind everybody in physics. So even if you haven't taken physics, just remember you all have an intuitive idea of what a force is. You know, the push when you press on something, when you press against something, or you pull, right? So that would be let's say that would be a force. And there is a formula, Newton's formula, which says that the force is the mass times acceleration. So, for example, if you drop an object and it hits the desk or your computer, so the way it falls down, the force that it's gonna hit the object that you drop it on is going to be, of course, proportional to the mass of that object. So intuitively, if you drop a heavier object, of course, it's going to have a more impact, right? So it's going to be proportional to the mass, but it's also going to be proportional to the acceleration. What's the acceleration? Is how quickly the rock or whatever object you drop goes towards the object that's going to hit. So that acceleration in if you simply drop something is going to be gravity. So that's going to be a bit of force, you know, that is gonna pull down, and generally. This acceleration here is the derivative of displacement. Remember, so in the case of a chemical reaction, it's how fast this chemical reaction develops, and when the type of energy that it develops. That's kind of the force that is important there. So that's why I gave you that earlier example. So the point is, you would want to calculate, you know, here that y is a function of x in this equation. And you'd want to calculate y prime and y prime prime, which would be the acceleration. We discussed about that earlier in one of the lessons when we defined derivatives. And you would want to calculate that, but you don't quite have a formula for y, so you don't know what exactly the formula is. You don't have something like this. If you could get something like this, the square root of x squared plus 4x cubed plus something, you know, under here there may be some cosine or some sine or something, then you would just apply the usual rules of chain rule, and then you know, whatever product rule or whatever you need. But you don't have one of these. So if you can get your hands on something like that, which in this case, by the way, you could possibly do, but it would be complicated. So if you can get your hands on a formula for y, do you still have a chance to calculate its derivative at some point, right? So yes, you do, and that's what the method of implicit differentiation tells us here. So I am going to do that here concretely. So if I don't know the formula for y in terms of x, how would I be able to calculate a derivative? And I'm gonna start with this particular formula. I'm gonna show you how that works. So you take the equation, you take the starting equation, x to the 4 plus x squared y squared plus y cubed equals 5. And remember that, now this is where that kind of, I told you, old-fashioned type of notation, dy over dx, is kind of useful. So you take the derivative of both sides with respect to x, folks. So that's what we're saying, d over dx. We do d over dx on both sides. So in other words, simplistically speaking, folks, so I'm priming both sides of this equation. So everything will be primed. All right, and that's the method of implicit differentiation. There's nothing more complex than that. And if I'm careful here and I calculate the primes and I solve for y prime, I'm all set. And I will be careful here indeed. So x to the 4 primed is 4x cubed. So again, just to emphasize, so the method of implicit differentiation is just priming both sides of the given equation. That's all there is. So over here, x to the 4 primed is 4x cubed plus. Now I gotta be careful here. So here's the deal. This is a product of 2x squared times y squared. So this one has to be prime. It's a product of two functions. Now remember that y, even though we don't see a y of x here, it is a function of x. So as I told you, you could potentially, find some sort of formula, especially if you work with series here, you could potentially find some sort of formula, but you don't know it. It's really hard to come about that formula. So you're still going to treat this y as a function of x, y squared, that is in this case, and you're going to do the product rule. So the product rule goes like this. So you're going to do x squared prime times y squared, and then you're going to say plus x squared times y squared prime. All right, so you're going to do these two. All right, this is the product rule. So the first one prime times the second one plus the first one times the second one prime. All right, plus, and then you're going to have here y cubed prime, which I'm not taking care of that right now. I'm just leaving it the way it is. Equals the derivative of 5. 5 is a constant, so the derivative turns out to be 0. All right, folks. So this is the formula that we are going to use. And right now, let's calculate. So we have 4x cubed. Over here, we have 2x for the derivative, right, times y squared plus x squared times. And now we got to be careful with this one. So this is the last place where we want to be careful here. So y squared prime. Remember, this y is a function of x. So when we do the derivative, we apply, guess what? The chain rule, the one we just discussed here. So that's going to be 2y, but we're going to say times y prime. Why did I not say, when I did the derivative here for x squared, why did I not say 2x x prime? I did say that, but I didn't need to say x prime because that's 1. So again, people tend to just say, okay, so x squared prime is just 2x. It's, again, x prime is 1, so you don't need it there. But for y prime, we don't know. Actually, that's what we want to find out, what y prime is. All right? And if you understood the explanation here, then this will be a piece of cake. Y cubed prime is 3y squared, and it's not just 3y squared, but rather, by the chain rule, 3y squared y prime. And that's going to be equal to 0. And now, my friends, we're going to isolate the like powers. So we're going to collect together the ones where we have a y prime, and we're going to factor the y prime from those. So on the left side, I'm going to say y prime times, and I'm going to combine these 2x squared and 2y. I'm going to say 2x squared y. Here we go, just to have them in alphabetical order. Nothing more than that. Plus, over here, I have 3y squared. And I'm going to say equals. And I'm going to move these other guys. I'm going to move them to the other side of the equation. So equals, and I'm going to say negative 4x cubed plus 2x y squared. And there we go. I have an equation at the bottom here, and the equation is easily solvable. And I can say the solution of this equation is, let me just, okay. So the solution is, sorry, folks, let me make this bigger. There we go. So the solution of this equation is, and I can say here, well, y prime is fraction, the right side, negative 4x cubed I'm sorry, so I made a mistake here. See, I forgot when I move things, negative 42 minus, they should have been minus here. So minus 2xy squared. I made a mistake, silly mistake here, but important. So make sure that you're careful. Minus 2xy squared, all divided by 2x squared y plus 3y squared. Now let's analyze. This is the answer. Let's analyze this thing here and let's see what happens. So is that a satisfactory answer? Given the situation that I cannot solve for y in terms of x, this is, folks, as good as I can do. But it's good enough because at least I have a formula that tells me what y prime would be in terms of x and y. Now, if I have a concrete situation where I know what x and y are for one point, this equation here represents some sort of curve in the xy plane. And what I'm really doing, I'm doing the tangent, I'm calculating the slope of a tangent line at various points. And if I know one point here on this curve, it's important to find the slope of a tangent line there. And if I know, knowing a point means knowing both x and y at some point, I could just substitute those concrete numbers here. If I had concrete numbers here, to substitute them in here, and I would find y prime. So that is the thing that we are looking for. And it's very important, folks, very important. And I will give you examples with that coming up. So do you have any questions here? Again, I don't want to insist on very abstract things. So most problems in the book are abstract like this one. This is even so what I'm going to do, I'm going to look for problems more like, and I will do number 28 here in the book. So any questions, folks? All right, so this is going to be our final problem here, if you want. It's a bit of a longer problem, but interesting. So number 28 in the book, in my opinion, exemplifies what the true nature of this implicit differentiation is. So it says that you have x squared plus 2xy plus 4y squared equals 12. And he says, you know what? Find the slope of a tangent line. Find, let me see, find the equation of a tangent line. Of a tangent line. The point of coordinates, and the point is 2, 1. Well, let's look together at this point on decimals. So I'm going to stop sharing this thing with you here. I'm going to copy I'll put the exact same equation in decimals. So let's look at decimals. Okay, so let's look at decimals, folks. 1 second, I don't have it open, that's a problem. 1 second. Let me, I forgot to open decimals. All right, so now decimals is open, and I am going to share that with you. Huh. Okay. Oops, wrong share, folks. Sorry about that. There we go. So this should be the one. All right, so I'm gonna graph this thing. So the equation is x squared plus 2xy plus 4y squared equals 12. And there we go. That's an ellipse, like they say in the book. And let's plot the point 2, 1. All right, we got this point over here that's right over here. And now let's see, let's look together. So if we were to draw a tangent line at this point, so this is a concrete situation. I don't have a formula telling me what y is in terms of x. I could figure it out by using the quadratic formula. You know, think of this as a quadratic equation in y, and coefficients will contain x, and I could figure out y equals, negative 2x plus minus square root of some complicated formula in x, and I could find the formula for y in terms of x. But the point is not that. The point is to be able to figure out the slope of this tangent line, and in fact the equation, just by looking at the graph. And if I look at the graph here, so if you look at my mouse here, it looks to me like this. So the point, this would be a line of slope approximately, slope maybe negative. So it goes 2 units to the right and 1 down. So it would be negative 1/2. Obviously negative slope, right? So that's pretty much what we expect to get with this problem. Let's go back to the drawing board and let's do this together, folks. All right. So we have this equation. Let's calculate the derivative. So we want implicit differentiation. Means doing d over dx, the derivative with respect to x of a formula x squared plus 2xy plus 4y squared equals 12. Over here we have 2. All right, so how do we do derivatives? Well, so we do derivative on both sides, right? So everything here gets hit by a prime. So we have x squared prime plus 2xy prime plus 4y squared prime equals 12 prime. All right, and it's very easy to see that on the right side we have 0 because 12 is a constant. And on the left side we have 2x because that's the derivative of x squared prime, plus for this guy here, I have to be a little careful. So when I do 2x y prime, I'm going to do a product rule here. So 2x and y. So folks, oops, okay, I deleted too much. So 2xy prime is the product of 2x and y. So it's 2x prime times y plus 2x times y prime. All right, so that's that. And then there's 4y squared prime, which is 8y. So 4 times 2y times y prime. So remember the chain rule over here. That's going to be equal to 0. All right, folks. So let's calculate the primes here, and let's figure out the problem. 2x plus 2x prime is 2 times y there plus 2x. Now I don't know y prime. This is what I want to find out. So basically the question is to find y prime at x equals 2, right? When x is equal to 2, plus, okay, we have over here we have 8y, which again doesn't change, times y prime equals 0. So what we have here, we need to find y prime at x equals 2. Now when x equals 2, we know that on the graph y is equal to 1 when x equals 2. So what I have to do here, folks, I simply need to substitute x equals 2 and y equals 1 in this formula here, and I'm going to get 2 times 2 plus 2 times 1 plus 2 times 2 times y prime plus 8 times 1 times y prime equals 0. Or if I do the calculation, so that's 4, that's 6, 4 plus 2, right? 6, so that's 6 plus, and then there's 4y prime plus 8y prime plus 12y prime equals 0. And right now I can see easily that y prime is negative 6 divided by 12, or negative 1/2. I can solve for y prime easily from here, which confirms our intuition that the slope of that line is negative 1/2. Now the equation of a line is very easy. So the equation of a tangent line, remember that the tangent line goes through the point 2 comma 1 and has slope of negative 1/2. So it's basically a very general problem about lines and equations of lines. It's the general equation of a line is 1 minus y minus 1 equals the slope, which is negative 1/2 times x minus 2. So this is the general equation of this line, and you can write it if you want to write. This is the point slope formula. If you want to write the slope intercept formula, just solve for y. So y equals you say negative 1/2 x. Over here on the right side, we also had plus 1/2 times 2. Negative 1/2 times negative 2 is plus 1. Plus 1, but then we have another plus 1 from here, so that's going to be plus 2. And that's going to be the formula for the tangent line. And now let's check that this formula works correctly. So let's go back to our picture and let's input this equation and let's see that that is the case. So I'm going to share that with you. All right, let's set up the equation y equals negative 1/2 x plus 2. There we go. Beautiful confirmation that, yes, that is the tangent line. So folks, on exams, I am going to allow you to use decimals. But be careful about, so be smart about using it. So I'm not going to put an implicit differentiation question on this quiz because we need to focus on some other things. So the material that we have up to this point, derivatives of trig functions, derivatives of with a chain rule, product rule, quotient rule, and such. So those are enough to test, enough material to test. But this implicit differentiation will show up on your test, which is in 2 weeks. And in 2 weeks, I'm going to ask you, well, here's an implicit, here's a function, here's an equation. And I'm going to say, here's a point on the curve described by that equation. So can you find the tangent line to that curve? So if you can, well, you have to go through the steps that we described here in the class. So the steps are the ones that are. Oops, a second, I'm looking at the wrong thing. So the ones here. So there we go. It's a little. It's always a bit of a challenge to switch between screens. But the work for the equation of this line was done, folks, was done over here when we calculated the derivative using implicit differentiation. So once you get, folks, once you get to this step where you evaluate all the derivatives, all the possible derivatives in x, leave the ones with y the way they are, because those you can't do anything about them. That's actually what you want to find. Find the slope by saying, well, here's the slope, the y prime, right? This is the concrete y prime, and then move on and write the slope intercept, point slope formula and find the equation of a line. That being said, folks, this is it for today. I'm not going to do anything further. So we are going to do a bunch of applications coming up in the following days. And again, we're not going to spend too much time on those because they tend to distract people from the main mission of calculus. Understanding the mechanisms of derivatives and later on antiderivatives and such. So, but we will certainly spend a little bit of time there, and then we'll move on to some further applications regarding the shape of a graph and things like that, which are more or less key to a lot of questions about minimum, maximum, and such. Applied questions for very useful questions for economists, for chemists, for biologists, for doctors, things like that, people like that, physics and such. All right, so I'm going to stop the recording here. If